In this video, we're going to continue our Investigating Life series. In the previous episode, we talked about Venus and its prospects, but the subject of this episode will be Mars and its prospects. In the preparation leading up to my research for Mars, I actually thought Venus would have the edge. But after doing the research, I was ultimately swayed in favor of Mars, and that's due to its unique feature in that it might have a habitable environment in its subsurface, which hasn't been investigated very well or thoroughly at all. The surface has been surveyed extremely well with survey orbiters and satellites orbiting Mars from land rovers and probes. We have a lot of data and evidence suggesting that the surface is extremely uninhabitable. But the geysers and measures of methane and the lack of geological activity for over 3 billion years makes the subsurface environment very stable, and stability is great for life because it allows any organism to adapt. And so I actually want to kind of preface this video by saying we're not really thinking about how life could have existed in the past and speculating about that. I don't really want to do that. And an easy way to prove that life existed sometime in the past would be to find a fossil. That's all you would need to do. Everything else, in my opinion, is speculation, and that's not really what I want to do. That being said, however, I am interested in seeing any evidence for a historical civilization or society that may have existed on a different planet. And that is actually where we'll start part 1 of this episode. And that is the viral structure image that we saw go viral on X, where it looks like there's a perfect square with perfect right angles, making a square-like, artificially made looking structure on Mars that doesn't seem like it could have formed naturally. But after my own analysis and looking at it very, very closely, I want to tamper down the excitement surrounding it and suggest that it is actually a natural formation. And I really want to break down why I think so. So I'll probably throw up the image of it on screen, and you can see how our eyes kind of want to perceive it as a square. And by the way, this is an unmodified version of the image. I got it directly from ASU, Arizona State University's database, where they manage all of the data. And so this is not enhanced or modified in any way. And you can also, I'll throw up on the screen exactly where the image was taken. And it was in a crater on Mars. And then I'll zoom in and show you exactly who found this structure. Whether that was a person, a scientist, or AI even for pattern recognition. Don't know how they discovered it, but here we are as we zoom in. And if you point your gaze or eyes towards the top right corner, you can see how there's a mound there. And I think about how could this form naturally, and you can imagine from the top right of the image, winds just pushing the sand-like material terrain of Mars in that direction. It could form a peak, form a mound-like formation, and then you kind of want to see a straight line going all the way down to the bottom right little peak there. But that's actually not the case. If you look really closely, you can see it actually curves off halfway down and then forms a ridge there. And that's clearly a natural formation of a ridge that curves off to the right. In fact, there's nothing actually going down from the middle of the right side to the bottom right peak. There's just nothing there. So this is kind of the evidence I have after looking at it that it's a natural formation. Obviously, the bottom left is just more rock formation and geological features. So that's just my point of view. We should definitely go there and investigate to confirm, but it is my perspective that it is natural. Moving on, we want to focus on the probability that life could exist on Mars, and I want to quickly just eliminate the surface. The chemical composition is 95% carbon dioxide, which is not great for the prospects of an organismal system. And so that combined with perchlorates, which are known to be toxic to living systems, although there's a recent study in Utah being done, or has been done, I'm not sure at this point, on a organism that actually uses it for its metabolic system. So you can imagine scenarios where something that is toxic or dangerous could actually be beneficial to a different life form. But for now, we'll treat it as a net negative. In addition, the atmosphere is extremely low pressure and very low temperature. Now, low pressure is not ideal for any structural system to form because most things will want to react to make a structure, but reactions don't take place very frequently at low pressures. And so they want to exist more so in the gaseous phase. However, low temperatures can offset this a bit. And so the temperature and pressure issue is not a huge issue for me. But I don't even think I detailed the temperature. The temperature is roughly 60 degrees Celsius at the equator, which is 60 degrees Fahrenheit, or 20 degrees Celsius, 15 degrees Celsius at the equator, which is perfectly acceptable. Everywhere else is very cold, or pretty cold. I wouldn't say very cold. Life could still exist at those temperatures, but it's not likely. Also, the lack of atmosphere allows radiation to penetrate the surface. It's roughly 30 times that which we experience on Earth because much of our atmosphere blocks it out. And that is very hazardous. And there's been studies that have been done where if you accumulate more and more lethal activities or lethal characteristics or environmental variables, the ability for life to exist plummets dramatically. So you can have one very dangerous hazard, but by the time you add 2, 3, or 4, it becomes extremely difficult for life to exist in that environment. And that is the case on the surface of Mars. So we can focus more of our attention on the subsurface. And there has been signatures that have been detected of methane, possibly coming from underground reservoirs. Like I mentioned earlier, the geothermal activity of Mars is very stagnant, and so there are actually no plate tectonics. It's just a giant thick crust that doesn't move. So you can imagine caverns being formed inside this very thick, rigid crust, and it's never moving, so they could exist for billions of years, which is perfect for a organism or some sort of life form to exist. A net negative, however, is that while it is protected from radiation, it doesn't have an energy source due to the lack of geothermal activity. It can't get sunlight. I don't know how it would be getting any of its energy. That is a net negative. Ultimately, we can estimate the probability to be 10 to the negative 3. And we can add that up as being 10 to the 0 for temperature, 10 to the negative 1 for pressure, 10 to the 0 for geological activity, very stable, great. So no penalty there. The chemical composition is unknown beneath the surface, but we can make the assumption that it is very similar to the surface. So we have water and methane, which is a positive, +1. You have -2 in perchlorates and -1 in carbon dioxide because it's 95% of the environment, which is not a positive. And so if you find the net difference in all of those, you get 10 to the negative 1. And any externalities or physical handicaps would be no sunlight or energy input for these creatures that could potentially exist down there. And so if you add all those up, it ends up to be 10 to the negative 3 is our estimation for the probability of life on Mars, which edges out Venus and is significantly greater than Mercury. So as of now, we should allocate resources based on my three episodes. We should allocate resources to looking at the potential caverns of Mars. In the next video, we will look at Jupiter. See you there.